Okay, good afternoon, ladies and gentlemen. We're going to continue our discussion on trigonometry 5.3. We're about halfway through this section, a lot of material in this. So far, every bit of trigonometry that we've done when we've used sine, cosine, and tangent and the inverse functions, we've always used the acute angle of a right triangle. Well, we know that not angles are acute. We have obtuse ones. So what are we going to explore today? We're going to explore this question. How can I do trigonometry on any angle? Why does it have to be just an acute angle in a right triangle? Can I perform trigonometry on any angle? And the answer to that is, yeah, we can. We're going to use something called a reference angle, which is kind of a cousin concept to something that we've already studied, a coterminal angle. And if you remember a coterminal angle, 20 degrees and 380 degrees are coterminal angles. Well, how do I know that? Because if I draw an angle of 20 degrees, and if I draw an angle of 360 degrees, it's going to look exactly the same on my XY coordinate system. So we're going to kind of, this is a cousin concept to that, reference angle. All right, so this is a 250 degree angle, obviously acute, and so how can I describe this obtuse angle as an acute angle so I can do trigonometry on it? I cannot do trigonometry on an obtuse angle. Well, what I can do is I can describe this angle as something else. And a reference angle is always going to use the x-axis. So instead of describing this as 250 degrees from the positive x-axis, an obtuse angle, I can describe it as 70 degrees below the negative x-axis, or I can say 70 degrees in the third quadrant. Remember, when we're doing this, one side of the angle always has to be the x-axis, be it positive or negative. So I can do this two ways. I can say this angle is 250 degrees, or I can say this angle is 70 degrees in quadrant 3, or I can say this angle is 70 degrees below the x-axis. 70 degrees, of course, being acute. All right, now I could say this, 20 degrees to the left of the y-axis, but I'm not going to do that. That is not going to work for me. It's one of the common mistakes students will make. They'll call this 20 degrees from the negative y-axis. And that violates our rule for a reference angle. A reference angle has to be made with the x-axis. So I'm not going to use the 20 degrees. I'm going to use its complement, the 70 degrees. Why? Because that's the angle made with the x-axis. Okay? That's the guy that we're going to use. That's the guy that we're going to do trigonometry on. All right, this is kind of a formal definition of reference angle. And any obtuse angle, I want to measure the obtuse angle with either the positive x or a negative x. Not exactly finding the supplement. Something a little bit different for that. Okay, in a nutshell, borrowing from the coterminal definition, it's not a true coterminal, but I am finding an angle that describes the obtuse angle with reference to either the positive or negative x-axis. Okay, here's an example, 345 degrees. What is going to be my reference angle for that? Well, let's draw 345 degrees. And I say, oh, well, that is 15 degrees below the positive x-axis. So I can do this trigonometry on 15 degrees in fourth quadrant, and I'll come up with the exact same numbers I need to as if the angle was 345. And that's the way we're going to do business. I'm not going to do trigonometry on 345. I am going to do trigonometry on 15 degrees in the fourth quadrant. Okay, what if we are in radians? Where is 5 pi over 6 radians? Well, that's over here at let me think about this, 150 degrees. What am I going to do? Well, I can say that 5 pi over 6 radians is the same thing as pi over 6 radians above the negative x-axis. And that's what we're going to use. We're going to use a pi over 6 in second quadrant. What if my angle is negative? What does that mean? Well, we know when we drew angles, what we did is instead of starting from the positive x-axis and rotating counterclockwise, we're going to start at the positive x-axis and rotate clockwise. All right, so 135 degrees, or a negative 135 degrees, is coterminal, or it's the same as a 45-degree angle drawn in quadrant 3, referencing the negative x-axis. What about this guy? 2.5 radians. Don't have no pi, don't have no nothing. I'm all confused and I want to cry. Okay, well, remember, pi is just 3.14, so we're not going to panic. All right, I can know that pi over 2 over here at 90 degrees is 1.57, and pi over there at 180 degrees is 3.14. So 2.5 is going to lie somewhere in between those two guys. Exactly where, really don't care. I know that I am in second quadrant. So if I take 3.14 and subtract the 2.5, that is going to give me my reference angle. So this 2.5 radians is the same thing as 0.64 radians drawn in quadrant 2. All right, so to make sure that we understand this concept, let's pause for a second. And let's do checkpoint number 5 together. And then when we finish that, check with each other, and then we'll resume. All right, welcome back. Let's take a look at checkpoint number 5, see how we did. We have 3 different degrees that we have to deal with here. And this is how we figured out the answers for each. 210. Turns out to be a 30-degree angle in quadrant 3. 7 pi over 4 turns out to be pi over 4 in quadrant 4. 240 degrees is a 60-degree angle in quadrant 2. And this last guy, 3.6 radians, is going to lie somewhere in quadrant 3. So I took 3.6 minus the 3.14, and I got this 0.46 radians in quadrant 3. Okay, well, we're going to resume this lesson in the next video.